Thank you for joining us tonight for our final RiverWatch Fall Speaker Series. Not our final series, our final presenter of this series. For those who are not familiar with the Illinois RiverWatch Network, RiverWatch is a community science organization that trains volunteers to monitor water quality in their own communities. The mission of RiverWatch is to safeguard the future of Illinois rivers and streams through stewardship, education, and sound science. Before we get started, I ask that you keep your microphone muted during the presentation to limit the distractions. We will have a Q&A session after the presentation, so if you have a question along the way, you can either enter it into the chat box to be answered at the end, or you can save your question and ask it aloud. And now I'd like to introduce our speakers tonight, Addis Moore, Jacob Decker, and Justin Shew. Addis and Jacob are currently working on internships with Justin at National Great Rivers Research and Education Center, or NGREC. Addis Moore has received his associate's degree from Lewis and Clark Community College and is currently in his last year at Southern Illinois University in Edwardsville, where he is working on his bachelor's in environmental management. After graduation, he plans on starting a career in the natural resources field. Jacob Decker is also in his last year at Southern Illinois University in Edwardsville, where he is majoring in biology with a concentration in ecology, evolution, and conservation, along with a minor in geographical information systems. After graduation, he plans on working in the terrestrial forest ecology field in relation to invasive species management. And Justin Shew manages the conservation programs at NGREC, including the Land Conservation Specialist Program and the Habitat Strike Team. And he's currently a member of the Illinois chapter of the Wildlife Society. His research focuses on wildlife associations to multi-scale habitats, with an emphasis on conducting research that may inform wildlife management decisions. And with that, I will hand it over to you three for your presentation.
All right, thanks, Hannah. I'll get my screen share going right here. Can everyone see my screen?
Yeah, you're good.
Good, okay. All right, well, hello everyone, or good evening. My name is Justin Shew. As Hannah mentioned, I am the Conservation Program Manager here at the National Great Rivers Research and Education Center. As Hannah mentioned, I do manage two programs, the first one being the Land Conservation Specialist Program, and there is a link there provided if you want to learn more about that program. But in a nutshell, we work with our funding partners, the Natural Resources Conservation Service, which is a federal agency, and we provide technical support for farm bill conservation programs, specifically the most popular private lands conservation program in the country, which is known as the Conservation Reserve Program. So for tonight, the showcase is Addis and Jacob and their work, but I do want to give you kind of some background information of how we kind of got to these projects, and that involves our Habitat Strike Team. So that is a group that I help manage. So I help hire the staff. I help go after grants that fund the team, write reports for the grants, all that fun stuff. But it is through the strike team and our funding sources that help us do these projects that complement what they do. So if you're not familiar with the strike team, here's an older version of our strike team a few years ago, but a strike team is a crew of folks organized within some type of organization. So here within NGREC, we have a 3 to 5 usually person strike team at any one point, and this team goes out and they do habitat management work, habitat restoration work. So this is not a team of folks with just a bunch of loppers that go out and lop honeysuckle. These strike teams generally have an arsenal of tools at their disposal. So here in this picture, they're on a prescribed fire. So this is our current UTV. This is a crucial piece of equipment to do habitat work more efficiently and safely. They also other tools in their toolbox include chainsaws, brush cutters, backpack sprayers. There's even a gas-powered, tank sprayer that they can put on the back of this UTV and really spray a lot of herbicide on invasive species. So the utility of the strike team is that they can mobilize very fast. So if a partner needs us to get to his prescribed burn, as long as we don't have any other commitments, they can, gather up their gear and go help and assist as needed. Another advantage of a strike team is that they can do, follow-up work a little bit easier. So, revisiting sites. So this restoration work takes a lot of follow-up. It's not usually just a few visits and you're done. To do it right, you need to go back to these sites, and that's what our strike team does. So as I mentioned before, I mentioned lopping honeysuckle. So tonight's talk is focused around this invasive plant species. So, and that's, what our current strike team is heavily involved with is control of invasive species. So the sites that we work on are very degraded. So, based on the intensity or severeness of the infestation, they'll choose to do different types of management practices. So here pictured are a variety of techniques. Up on the left, that's Cody Berry doing some backpack spraying. To the right of that picture is a cut stump treatment. So they're, cutting the honeysuckle with a chainsaw, and then the lower right, you would apply an herbicide solution to those stumps to kill the plant. Also, as I mentioned before, prescribed fire is a great tool. All the green you see there in that picture in the lower left, that is emerging honeysuckle in the spring. So if you run a fire through there, you can get a lot of kill on that invasive species. So that's another technique to manage. Ideally, you want to get these sites to a point where you can just manage them by fire. So, but sometimes depending on the situation, you have to do different things. So you see a picture of a helicopter. No, we do not fly helicopters on our strike team, but our partners sometimes contract work out to companies that can do aerial application. So that is when you have a really bad infestation, typically of honeysuckle. If you can do an aerial spray, you can of course cover a lot of ground versus doing the backpack spraying and the other sorts of boots on the ground techniques. So, the strike team, the goal is to get, restore habitat, and that first starts with the plant community. So here is a picture of a site on the right that was heavily infested by an invasive species called winter creeper. And so they were able to remove quite a bit of that invasive species, run a burn through there. And then, you have, native spring plants emerging. This is a mayapple. And so once you improve that plant community, hopefully you can improve, the insect community and improving the base of the food chain. That in turn might help with other species like, brood rearing turkey, and on and on. So the goal, of this work is to, improve these habitats, and you first start with that plant community. Then ultimately you can have people come onto these areas and enjoy maybe better hunting opportunity or just hiking and bird watching experiences as well. So, that is of course another goal of some of our partners and what they're trying to do. So as our title suggests, we're focusing on bush honeysuckle tonight. There are a lot of other invasive species that our strike team works on, but I would say probably 75–90% of their time is focused on just getting rid of honeysuckle as best they can. So that's why we're focusing on that plant tonight. And if you're not familiar with bush honeysuckle, it's a non-native deciduous shrub that came over from Asia. It can grow up to 20 feet tall. It has opposite leaves, and if you touch the leaves, they have kind of a fuzzy texture to them. They do have white spring flowers, and then in the fall, this time of year, you can really identify them well with those red fall berries. Unfortunately, the birds do eat a lot of these berries, and that's how honeysuckle can spread. So in terms of a management standpoint, you really want to try to get that honeysuckle before it is at a mature stage and actually has the berries. One reason why it's a very invasive species is because it simply grows really fast and early. So it's going to outcompete a lot of the natives for sun and resources. It's one of the first things that greens up in the fall. However, there is one aspect of honeysuckle we can use to our advantage, is that it has an extended leafing period into the fall. So once native plants go dormant, you can go in with, aerial spraying or some heavy herbicidal application, and you don't have to worry about the natives as much. So again, this is a really bad invasive species here in the Midwest, also out east, up in Canada. It's very prevalent. So if you're not familiar, here is, some honeysuckle. These plants are probably 10 to 15 feet tall. I just want to point you to the forest floor. Notice that there's really not many species so there's basically no species diversity in that herbaceous understory layer. And this is what honeysuckle does. Once it gets to a point, it's just outcompeting a lot of those species. So there's just very low plant diversity in these areas. And also in terms of, if you're a hunter, walking through this stuff is really challenging. So this is at this stage here. You have to like crouch down, duck through this stuff. You hurt your back. It does grow taller. It gets a little bit easier to walk through, but a lot of it does look like this, and it's just really challenging to walk through. All right, so I know this is the RiverWatch group, so I wanted to bring in some macroinvertebrates into the talk tonight. And there is studies that show if you remove honeysuckle from certain, in this study in the headwater stream, they actually saw improvements in macroinvertebrate density and also functional feeding gills. So what you do, again, on the uplands can have direct impact on what's going in the aquatic habitat. So I just want to mention that to the audience tonight. So I'm going to have Addis and Jacob talk about their projects. So one of the things I do at NGREC is mentor interns, and this is probably one of the most rewarding aspects of my job. And actually preparing for tonight is like, oh, I should try to get a picture of everybody. And so it's quite a few interns. Again, it's all our projects are kind of involve honeysuckle and wildlife. So I'll go through very quickly a couple of those projects and show you how it all ties in with the work that Strike Team's doing. So this is Phil Rates. He's a member of our current Strike Team. And unfortunately, he had the opportunity to do his internship during the pandemic, but he did a great job. We had a bird data set, and we specifically look at some of the species that are important to Illinois. So these are the species of greatest conservation need, so the SGCN. And although it's not a super strong relationship, as there was more honeysuckle coverage at these sites, generally we were counting less of these species of greatest conservation need. Notice how on the right are some of our sites. It would be nice to have more sites with more higher infestations of honeysuckle. So moving into, most of my background is studying birds and habitat associations, but we had John Crawford here at NGREC had some camera traps that we were able to use. And Jacob Decker, who's going to talk tonight, his first internship with me was deploying these camera traps at certain sites in southwestern Illinois. And again, looking at kind of this mid-sized mammal and also wild turkey response to honeysuckle. And again, what he found is generally there is a negative response to these species and this more or less mid-sized mammal community. going along with the wildlife ecology theme, Addis's first internship with me as well was with this camera trap data set that Jacob helped establish. So we're just trying to build upon these data sets as best we can. And Addis, I think I asked him and he's like, oh, let's look at wild turkey. So Addis looked at wild turkey, and I would say this relationship is, there's hardly anything going on here. And as Hannah mentioned, what we like to do in our lab is look at habitat from a multi-scale perspective. So maybe honeysuckle itself isn't the greatest predictor of where we're finding turkey. However, Addis looked at some other habitat characteristics, and what he found was that, distance from road and also the amount of core forest area might be better predictors of when we're detecting these wild turkey on our camera traps. So just to show you, it probably depends on the wildlife species, but habitat can be things like honeysuckle, but it also can be things in terms of, what's going on in the landscape. So it's pretty complex to kind of tease these things apart sometimes. So with that, I want to turn it over to the showcase of tonight, and that's Addis Moore and Jacob Decker. It's been a privilege to work with them over a year or more. I've seen them grow professionally and mature, and so it's just been an honor to work with them, and I'm really excited to have them talk specifically to you all about their work. So I'll have Addis. Addis is going up next and talk about his project involving shifting gears from the turkey and looking at honeysuckle removal and woodland restoration. And Jacob's doing really cool stuff with remote sensing and showing how we can build upon and actually maybe quantify honeysuckle at a much larger scale than going out into the field and measuring it yourself. So Addis, with that, have you go next.
All right, everyone. My name is Addis Moore. Unfortunately, I did wake up today with 101 fever, so if I don't sound too great, that's probably why. So just bear with me here. So my project is stemmed from, I'm looking at like all these turkey populations, and I'm looking at Jacob's previous studies. Honeysuckle, has a negative correlation with animals and is bad for the environment. But I just wanted to kind of switch gears as a way we can get rid of it now. So that's using the EasyJect Lance. I also wanted to add in a native seeding part to my restoration. So this is what my project's on. We can go to the next slide. All right. So this is the Lance here. I read about it in a study from 2004, I think. They were using it, and I thought that could be pretty effective for honeysuckle removal. So basically, it's like a 4-foot lance. It has a gravity-fed injection tube. You fill it up with a bunch of capsules. It can hold 400 capsules, and inside each capsule is like 90% glyphosate, which is basically the chemical they use in Roundup. Super easy to use, doesn't require a whole lot of force, or it's not labor intensive or anything. You kind of just push it, and it injects these little capsules into the bark of the targeted species. For this lance, you don't need licenses or training involved, which you would need in other removal techniques. Another plus about this is that it can be used in any weather, so it's very targeted towards the species. You're not getting any overspray. It's injected into the species that you want it to be in. So we wanted to try using it in winter because it's kind of easier walking. You're not sweating as much. And no one's ever studied the effectiveness of using it in winter. We can go to the next slide. So a little justification, I kind of already hinted at it. Most methods required to eradicate honeysuckle, you would need technical skills. That's for like using chainsaws or backpack spraying. You also need herbicide license for backpack spraying. You're mixing chemicals also. Cutting and painting the honeysuckle is pretty intense labor. I've done it before. Wasn't very fun. So I'm just trying to think of, easier way to get rid of this honeysuckle. And also with aerial spraying, you have a short time frame of when you can aerial spray. You need pretty good weather conditions for it. So not always can that line up for aerial spraying as well. So I'm just kind of looking at an alternative method that could possibly benefit strike teams. Go to the next slide. Some of the objectives of my study. We obviously want to assess how effective this lance is during the winter injections. Previous study assessed its effectiveness during the fall injections. Said it was very effective, but really wanted to see what it would do in the winter and just overall because it seemed too good to be true. We also wanted to add in woodland seeding during the fall to see how that would affect the plant community because I know like a lot of these removal techniques, they just get rid of the invasive plant and then leave it. More invasives take over. So we want to see if we could remove these invasive plants and seed at the same time to kind of establish a new plant community before other invasives come take over. This also, we want to provide useful information to land managers and habitat strike teams with effective methods of restoration. Next slide, please. So the site that my study took place at, this is in Godfrey, Illinois. So it's like Southwest Illinois. It's a Lewis and Clark Community College campus. It's a pretty degraded woodlands. It's very infested with honeysuckle. That's why we kind of chose this site. And all these little red dots you see on the screen here, those are northeast corner of study blocks. So each block is a 20-meter by 5-meter area. And we divided those into 4 subplots, which on the next slide, I'll kind of introduce what we did in each subplot. So let's go to the next slide. So at the bottom right, that little graphic you see there, that is the entire block. We divide it into 4 subplots. So each subplot got a random treatment. These are in no particular order here. I'm just going to go through them. So we have 40 subplots total, 10 blocks. So there's 10 types of each treatment. So the first treatment was fall seeding. So that's all we did there is we just raked the floor of the woods and seeded with black-eyed Susan, inland wood oats, and northern spice bush. So that's a flower, a grass, and a shrub. We did that December 15th and 16th of last year. And then we had the control. You just leave that alone. We didn't do anything with it. Next is the winter injection. So that's when we use the EasyJect Lance and we injected the capsules into the bark of the honeysuckle within the subplot. So we did that January 11th of this year. And then the fall seeding and winter injection is we did the injection and the seeding in the same subplot. So it's a kind of a combination technique here. Next slide, please. So on to the methods. So we collected a lot of data for this project. So we took pre-treatment data. So this before we did anything, we recorded that 2022 in October. This was kind of like general vegetation data, honeysuckle cover, honeysuckle diameter, general veg stuff. We also took some like overstory cover, stuff like that. Just so, we could kind of make sure that all of our subplots and blocks are pretty similar in habitat types. So then we did our treatments, and then we started recording our post-treatment data in June of this year. So that's me on the right there, recording some post-treatment data. This was fine scale, I would say, vegetation data. So we had a 1 by 1 meter quadrant that we placed on like the midpoints of each subplot. Here we collected species, plant species type, and their cover, and we use that to estimate the cover for the subplot. And then we also collected alive and dead honeysuckle data in July to see how effective the lance was in killing it. We also collected honeysuckle capsule data on October 4th and 6th, so pretty recently. That was kind of to see how many capsules were used per honeysuckle plant, like what the diameter was with that. Next slide, please. So on to the results. We got a lot of them. So this is our pre-treatment data. So this is before anything's happened. This is honeysuckle cover within each treatment type. So, we wanted to collect this data to make sure that there was no bias in any different types of treatments with honeysuckle cover. And as you can see here, that they're all very similar. So that's good. Next slide, please. So this is the post-treatment honeysuckle cover. So after we did our treatments, the percentage of honeysuckle cover that's on the left side, and then treatment types on the bottom. You can see that the injection plots have significantly less honeysuckle cover than the other ones, and they would have a lot less. But in our original data collection of honeysuckle cover, we counted plants that overlapped into the subplot but weren't actually in there for the cover. So that's why they have a little bit more cover than expected. Other than that, though, pretty good result. So next slide. So here we have average plant species richness. So this kind of just gives us a look at, the plant community a little bit within each treatment type. So as you can see, the control has a very low richness. The fall seeding and the winter injection and fall seeding have pretty high plant species richness within their 5 meter by 5 meter subplot, so that you can see there's a clear difference. It is helping plant species richness with you doing the injection and seeding treatments. Go to the next slide. So this is a little more fine-tuned species richness thing. So it's FQI or FQA. So basically each plant species is assigned a C score, conservation score. That score is given to them based on how easy they are to grow in habitats. So like honeysuckle would have a C score of 0 because it can grow pretty much anywhere. Let's say, I'm not for sure on this, let's just say oak trees have, a C score of 5 because they need a better habitat to grow in. So like plants that need better habitat will have a higher C score. And you calculate your FQI values off of that. So you can see the areas with fall seeding and winter injections, they do have higher FQI values than the controls, which is expected. So next slide, please. This is just a picture of the 1 by 1 meter quadrant that we use to calculate these graphs here. And in the bottom left of the quadrant, that is actually the black-eyed Susan that we planted in this plot. It's very young. It still hasn't blossomed to a flower yet. So next slide. So here's a graph on alive honeysuckle plants versus dead honeysuckle plants. You can obviously see in the control and the fall seeding, they're all still alive. We didn't inject them. Both the injection plots, they have quite a few dead. Some are still alive. Around 70% of them are dead honeysuckle plants. Either the alive are due to they were too small to where we couldn't inject them, or that there was a little bit of growth coming out of the bark after we injected it. So we consider that alive. If you want to go to the next slide, I can explain what I mean by that. So you can see here on this honeysuckle plant that it's injected. It has no leaves. It's just there. But this little green deformed stuff coming out of its bark is alive. So we do have to consider that alive. So that's what a lot of those alive plants you see on the injections. So that's kind of what that is there. Next slide, please. So little conclusion here. Um, the winter injection fall seeding combination subplots, they have significantly higher species richness, FQI values than control plots. Injection treatments significantly lowered the honeysuckle cover than control and fall seeding subplots. That's the expected result. The lance is mostly effective. We'll say 70 to 75% effective. Uh, One possible way it could be more effective is if maybe you use more capsules in the honeysuckle plants, which we think that's probably why some of them had those growths coming out of them. Another thing Justin would like to do is take this in a future direction. I would like to see it taken up by a future intern as well, because there's no studies, showing a restoration on honeysuckle, you know, 5 years down the road or 10 years down the road, and we kind of want to see what this habitat looks like. If it's a one and done thing, or do you need retreatment every few years or retreatment every year? So it'd be interesting to see if someone picks up this project. So we just have a picture here. On the left is non-injected honeysuckle. On the right's injected honeysuckle. So you can see huge difference between them. Those were taken May 23rd. And with that, I'm going to pass this off to Jacob Decker, who is looking at honeysuckle through a different point of view than me. He's more on a large scale thing. He's more about identifying the areas that are kind of needed in the restoration of honeysuckle. So I'll pass it off to you, Jacob.
All right, thank you, Addis. So yeah, like Justin said earlier, I've been with NGREC for a few years now, coming up on 3 years off and on throughout the seasons. And I actually started with the Habitat Strike team myself, and so I got actually firsthand experience in what it takes to manage these areas with high dense areas of honeysuckle. And also I've done that mammal study with the responsive aerial spraying, and then some floodplain stuff last summer, and now I'm going back to this project that uses Google Earth Engine to quantify bush honeysuckle coverage. And the main application for this process is a GIS application that's called remote sensing. So now, next slide, please. So remote sensing is the science and art of obtaining information about an object without coming into direct contact with said object. So you might think, how is that even possible? But actually kind of way more simpler than you think, but I'm going to try and explain to you here. And this is just an artist's representation of a satellite image, a satellite that's using remote sensing techniques on the ground. Next slide. So most satellites that I am using and the data set I'm using, most satellites need a source of energy to obtain this kind of data. And the main source of energy is from the sun. And that is light energy that is transmitted as called electromagnetic radiation. And that top black bar there is just the graph of all the light bands, and they're from short wavelengths to long wavelengths. And right there in the middle is the visible light range. So that small area is the only thing we can actually see with our eyes. And there's so much more information within the other light bands that we can't even see that has so much more valuable information that we can mess around with and play some games with to get some interesting results. Next slide. Yep. And so how it kind of works, this is the process of it. And so you have the source of energy, which is the sun, and then all those light bands get hit an object, and then that object actually either absorbs the light, reflects the light, or transmits the light through that object. And then the satellite sensor picks up on those absorption and reflectance levels, and then it sends that data into a receiving station, and then we can then do analyses and interpret the data, and then hopefully use it for the real world application. So actually, there's a couple bands of light that are a very good indicator of biomass, and those are the red and near infrared lights, the red light, and then it goes near infrared on the other side of the spectrum. And plants do this weird thing where, you know how they have chlorophyll in them, and the chlorophyll gives it what the plant has, that green color to it. And the chlorophyll actually absorbs red light, puts on that green color, and then reflects near infrared light. And then, so we can measure the absorption of red and reflection near infrared to kind of scale how green a plant actually is. And that is called the NDVI, which is just the normalized difference vegetation index. And it's just a measure of vegetation health and greenness. So if plants have a really green, they'll have a high NDVI. As you can see there, it's absorbing 8% red and then reflecting it's reflecting 8% red and reflecting 50% near infrared. And then if there is a plant that is going dormant like this time of year, it's not going to be such a, so it's going to have a lower NDVI value, meaning that the plant is not as healthy or just not as green at the time. And there's that little equation right there. It's just a normalized that puts the index from a scale of -1 to 1. Next slide, please. So here is one of the images from my camera trap study, and this was really helpful to use in the validation of what time of year and when I need to get these satellite images and what time I need to use for them. And like Justin said that earlier, that bush honeysuckle has a phenomenon called with the extended leaf phenology, so it just stays greener for about a 2-week period past all the overstory native vegetation has already lost its leaves. As you can tell in this image, all the trees have already lost their leaves. The honeysuckle there is still green, and with that, those light bands can be analyzed and can pick up those reflection and absorption levels of the green vegetation. And there's actually a little squirrel there in the right-hand corner behind the tree. You can kind of see his tail right there, but we're going to move on from that. So the main application that's in my title is the Google Earth Engine. And Google Earth Engine is a cloud-based analysis platform that utilizes remote sensing and satellite imagery. And it actually has data sets that go back to 40+ years. And so you can access these data sets and go back in time and just view what the landscape looked like in whenever time you wanted. And then also utilizes geospatial data sets like elevation, terrain, and climate. And those are also just very helpful in running analyses for what you're trying to study. And it just uses a common JavaScript coding language to help insert and manipulate the data once you have it in your map pane. And the best thing about this program actually is that it is free. So it's a really interesting how they made this free, and it surprises me still every day because it has so much data and so much compatibility and so much power you can use to classify these images and get results from it. So that's actually really cool. Not many programs like that are free. Next slide. And actually, this past fall, I actually got the opportunity to go to a Google Earth Engine workshop in the Google headquarters at Seattle. And this is the front main entrance I took a picture of. These buildings are really cool. Such a great experience. We'll never forget it. And I actually got to sit down and meet with the people that developed this program and go over with my project to them one-on-one, face-to-face, and they were able to give me tips and tricks, or tips or some ideas to kind of help boost my study up a little bit more. And it was also very helpful because they were able to teach me ways to combat problems like this, which is a very, as you can tell, this is a satellite picture just above my study area. And it's, as you can tell, it's very cloudy. So clouds are a big problem in remote sensing. That they just view the data. You can't really get much information on the ground from these clouds. And there's a way to actually call cloud-based analysis and coding. You can actually remove these cloudy pixels and insert them with fresh new pixels from different image dates and kind of create a mosaic of a cloud-free image, which is pretty insane if you actually think about it. But that is more complex, of course. Not really going to go about that much today, but that is available information on how to do this kind of stuff. So next slide, please. So just the objective of the study was just to quantify bush honeysuckle coverage in correlation with that NDVI value from Google Earth Engine, and then produce a model that can be beneficial to managers for monitoring and detection of bush honeysuckle. Next slide, yep. And then, so we used, I had 24 data points or site locations that we used. They're at 5 different public and private lands. And after this area is right near St. Louis. It's right across the river from on the bottom there from Alton to St. Louis. So it's in southwest Illinois. And then a lot of the data is about, I think it was 9 data sites are actually in Pierre Marquette, which is the largest state park in Illinois with 8,000 acres. And there's a lot of honeysuckle there that needs to be eradicated. So it's pretty cool to get on that site and work there too. And then next slide. Within each site, we kind of did a vegetation index for my previous study, and that's the data that we used. And so at each of those white squares there on the left picture is where we did a vegetation index of bush honeysuckle, kind of measuring the coverage in each area. And then that kind of totaled up to be a 50-meter area that circle is. And so we just averaged out all the bush honeysuckle coverage for that area. And that's how we got our honeysuckle coverage within each site. And then on the right there is just us taking the measurements. And let me tell you, doing this stuff in a large scale data collection is not that fun, trying to count all these bush honeysuckle stems and going through them and stuff. But next slide. So let me get into the actual images part of this slide. So we use right now, I'm just going to focus on the Landsat 8 image collection, and that's actually a picture of the satellite that's called Landsat 8. And this satellite was launched in 2013 and is at a 30-meter scale. So what that means is each pixel, so every image that you see on the TV, on whatever, are made up of pixels, and each pixel represents 30 meters on what is on the ground. And then there's also Sentinel-2, which is a newer one that was launched in 2017, and it uses a 10-meter scale, so it's even finer. And there's also very new that we got released in like 2020 called Planet satellites. They actually go down to 3-meter scale. So messing with these different ones can be really cool, really fine scale imagery. But then after that, we use a filter the image collection to desired a date. And we use that image collection and fit it to our area of interest, which are my data points. Next slide, please. So now it's all about finding the perfect image date. So like I said, we use camera trap pictures to kind of look at these and see what images or what dates fit best. So November 20th, 2021, we use that image to see if that green honeysuckle was the only green vegetation, and all the other overstory native vegetation was already gone. And then we also needed a winter image where it had no vegetation at all, which I'll explain here in the next few slides on why we needed that one too. Next slide here. So this is actually the map interface in Google Earth Engine. So that is just a tile of a Landsat image right there. And this is on November 20th, 2021. So you can just filter out all these images that have like over 3 million images in it and just get you one single image on the fly. It takes only a couple seconds with some code. And then that highlighted rectangle is my study area. And so I just need to clip that little rectangle, clip the image to that rectangle. And then that is the only thing we need to focus on. Got lucky with the clouds because the clouds are to the left, so they're not going to mess any of the data up. And then next slide. So here is what the NDVI kind of represents on an image, on a visual aspect. So like I said, NDVI is an index from -1 to 1. So anything with no vegetation is going to be really dark. And that's how you can see that water is the Mississippi River right there. And so yeah, that's water, so there's no vegetation at all, and it's really dark. And then as a lighter, if you get more lighter white areas, that means there's vegetation there. All the white squares you see are most likely ag fields that have some kind of winter wheat or cover crop, and then maybe some grassy areas, but because this is the fall time. But those are not the areas I was really looking at. We can go to the next slide. Then after we get that NDVI image laid out, I can create a buffer around each data point, and the buffer would be 50 meters. That corresponds to the honeysuckle coverage that we did, 50 meters, and just extract that NDVI value within each buffer. And then after we extract the NVI value for the fall and winter, we take the winter and subtract it from the fall image NDVI values. This is done to kind of correct for that biomass that might be still left over in the wintertime, like you have your evergreens, so they stay green the whole wintertime. And then maybe some grasses that do too. So you can just, this subtraction just kind of can't be hanging on into the wintertime. Next slide, please. So here are my results. So this is just all the data points being in use here, and there's a correlation between the NDVI value and the. So NDVI has a pretty good correlation to this, but we noticed that it could be better. That 0.4, if the closer the value is to 1, the better the correlation is. So that 0.4 is okay, but we noticed that it could be better. So on the next slide here, we just kind of split up the coverage data. And so since I said this is Landsat imagery, it's at 30-meter scale, that's kind of a big area. And so every data point that had over 30% honeysuckle coverage, it had a very good tight correlation at 0.9 pretty much with the NDVI values. And all the lower coverage areas are kind of getting just misread and not really getting picked up that well because of that such a large pixel size. And that's where we would use a smaller imagery scale to potentially make the study even better. So yeah, it's just a really interesting how NDVI and sound imagery can pick up high density areas of bush honeysuckle. So next slide, just gonna wrap everything up. So yeah, like I said, best correlation at sites with 30% or above bush honeysuckle coverage. So just more dense areas when using Landsat imagery. And then NDVI was a pretty best predictor model that we can compare to measured values. And then ultimately want to gain some ground truth data for areas with high density honeysuckle coverage, and then correlate those back into the satellite imagery and can kind of pinpoint what areas are actually doing, pinpoint high dense areas within true ground truth data. And then ultimately use smaller scale image collection. I plan on the next semester using that 3-meter scale stuff. So hopefully get some really tight fit correlations and improve the data accuracy. And then always just get better at coding, using that cloud-based coding stuff and using Google Earth Engine to ultimately better the study. All right, that's about it. Thank you guys.
All right, thank you to all three of you for presenting, and especially Addis for presenting while being sick. Does anybody have any questions for any of them? You can either ask them aloud or put them in the chat and I'll read them. Okay, I'll start with a question. I guess this is for Addis about the Easy Lance. Is this a tool that can be used by like people in their backyards, or is this more for like actual natural resource managers type of thing?
I mean, I would say both. I mean, it's like there's no licensing or anything you need to get one. All you gotta do is pay for it. And I've read some reviews on it that some people do just use it to get rid of trees that they don't want in their backyard. But I've also seen, other studies using this to get rid of other invasive species besides bush honeysuckle. So I would say both.
Okay, cool. Don asks, what is the cost of the lance and the cartridges?
So the cost is pretty expensive, but depending on what size you get. So they have a super small one, like a medium sized one, and the large one, which is what I got. The large one's around 500, medium's like 400, and then I think the small one's 200. So the difference is just the size and how many capsules they can hold. So the super small one can hold 100, medium can hold 200, and the large one can hold 400. Capsules are 19 cents a capsule or something. They're fairly cheap. And they're just little 22 rounds filled with glyphosate, so it's not super expensive.
Okay. Okay, this is a question for Jacob. Since oak leaves don't fall off in the fall, how well do you think the remote imaging works in oak hickory forests?
Yeah, that's a good point. Some they do like to hang around the tree, and but since since they're no longer green, that near infrared and red correlation is going to be way lower than the honeysuckle that can still get penetrated on the ground and make it to the satellite imagery. So ultimately, that I think is still a good remote sensing will work for oak hickory forest, since it's just not green leaves anymore.
Okay, thank you. Okay, I think this one's for Addis. When used in natural areas, is there any risk to someone who may not know what the red things on trunks are and they try to pull them out?
So what the capsules are on the trunks?
Yeah, I think that's what they're referencing.
I would say I don't think anyone would try to pull them out. I mean, they're super small. You can barely see them when they're in the trunks. There maybe be a risk if you did it the week of or the day of that you inject, because it is 90% glyphosate, which is fairly harmful in large quantities. But I would say, because when we went to go check again for um, our post-treatment data, the capsules, one of them did fall out and it was completely dry, so there was nothing left in it. So I think it's fairly safe after a little bit of time.
Okay. And then do you expect there will be natural regeneration of natives or more baby honeysuckles coming up under the ones that were killed?
So I do expect more of the honeysuckles coming up underneath, because I don't think, because they already have an established seed bank wherever they are. But I do think that, with the introduction of native seeds, that can kind of help push the native plant community in the right direction and kind of give them a little advantage over those honeysuckle seeds that are already in the ground, and help outcompete them. But that's why we did the seeding part with it as well, because a lot of these restorations just kind of leave after they've taken them out, and the seed banks are still there, so they just grow right back.
Okay. Does anybody else have any more questions for any of our three speakers? Okay, I'm gonna go ahead and close this out then. Thank you again to all three of you for coming and presenting for us tonight. I just have a couple of reminders. So this was our last speaker of our fall speaker series, but we are working on scheduling and we'll be announcing our winter speaker series in December. So the announcement comes in December and then the speaker series will start in January. And then I just want to mention that our Chloride Watchers program is currently going on. So we do still have a couple of training sessions between now and December 6th, both put on by us and then also our partners at the Conservation Foundation. And you can find links to registration for any of our events on our website on the events page. And then you can also look out for more activities on our Facebook page. So thanks again for everybody for coming and for our presenters, and good night.